Starting with the next exercise, solving the important questions here. So we have two questions, important questions from exercise 4.2. The very first one is prove that a determinant of 3 cross 3 matrix is given and we have to prove that this is equal to 0. Alright. So what we have seen in the synopsis is whenever you are trying to evaluate a determinant, you have to always evaluate the particular row and column which has maximum number of zeros. Alright. So here, as we can see in the given determinant, there are no given zeros. So we'll do one small operation here. So we will do the operation. We'll start with the solution. Solution. Let us operate like this. Let row 1 be operated such that row 1 plus row 2 plus row 3. So to row 1, we will add row 2 and row 3. See what will happen. So determinant of. So row 2 and row 3 are untouched, right? So write that as it is. B minus C, C minus A and A minus B. Here we'll have C minus A minus B and B minus C. Now see this operation, students. So here what we'll be having, row 1 as it is, A minus B, row 2 plus row 2, right? So it will become plus B minus C, plus row 3, that will become plus C minus A. So plus A minus A, plus B minus B, plus C and minus C will get cancelled. What will remain here? 0. Correct? Same thing, plus B minus B, plus C minus C, plus I minus A will get out cancelled. Again 0. Same thing will be getting a 0 here again. So what is left out now? So we are getting zeros in this. Now expand or evaluate this determinant with respect to R1. So before we start with the evaluation, we'll write the cofactors here, plus, minus and plus. So we'll be having plus 0 of determinant of C minus A minus B, A minus B, B minus C. So whatever the determinant we are getting here, this is getting multiplied with 0. So whatever gets multiplied with 0, the answer is what, students? The answer is 0 itself. So again minus 0 into something, so that is 0 only, plus 0 into something. So this will be equal to 0 minus 0 plus 0, which is equal to 0, and we got the right hand side. Now here, if you try to evaluate this determinant as it is, okay, so here we finished within some 3 to 4 steps, right? So if you evaluate this determinant as it is, you will be getting 0, but the number of steps will increase. So just to reduce the number of steps and also to save your time, we are doing this operation. So from this operation, what is happening? The row 1 is becoming 0. Since row 1 is 0, so if you evaluate this determinant with respect to row 1, you will be getting the answer as 0. So doing this method is recommended. Okay, doing this method is recommended. Moving on to the next question. Prove that determinant of 2, 7, 65, 3, 8, 75, 5, 9, 86 is equal to 0 again. So again, there are no non-zeros, non-zero rows and columns are very less here. What we'll do, the operation here is solution. Here we'll carry out the operation column 3 is equal to column 3 minus column 1. See what will happen to the given determinant. So column 1 and column 2 are as it is, right? So write that as it is. 2, 3, 5, 7, 8, 9. Now 65 minus 2 is 63. 75 minus 3 is 72. And 86 minus 5 is 81. Now why did we do this operation? And how do we know that we have to conduct this operation? Very simple, students. So just observe the numbers. 65 minus 2 is 63, right? And 7 9s are 63. Note this. 7 into 9 equals 63. 8 into 9 equals 72. And 9 into 9 equals 81. So what can we tell this now? Are these both columns? These both columns are what? These both columns are proportional. Okay, and the very first in the synopsis, the very first property what we have discussed in the classes, if any two rows or columns of a determinant are identical or proportional, then the value of the determinant is 0. So now what we'll do here to make, so this is proportional, right? So we'll make it identical. How do we make it identical? We'll write it like this: 2, 3, 5, 7, 8, 9, 9 into 7, 9 into 8, and 9 into 9. We'll take out this 9 outside. Okay, this 9 will take it outside, common. So what will happen? 9 of 2, 3, 5, 7, 8, 9, 7, 8, 9. Now what is happening? See here, these both columns are identical. So if they are proportional, you can express this column like this, and you can take out 9 common like this. So what will happen? These both columns will be identical. So if two columns of a determinant are identical, then the value of the determinant is equal to 0. How do we know this? From property 1 of determinants, which is equal to RHS. Therefore, hence proved. So students, see this. If it is proportional, directly you can write 0. I just showed you how will that become equal to 0. So expressing it as a product, taking out 9 common, then it will become identical. It will become 0 here. So as soon as you see any two columns or rows are proportional, directly you can write 0 here itself. Understood? Moving with the next problem, students. So again, the question number 5, prove that the left hand side is given. We have to take that and get the right hand side. Alright, let us start with the solution. Solution. Okay. So determinant is given like this, and we have to get the right hand side. 2 times of APX, BQY and CRZ. So the very first step what we'll be doing here is, we will multiply the row 3, or row 3 we will consider and do this operation. Row 3 equals row 1 plus row 2 plus row 3. So add row 1 and row 2 to row 3, see what we'll be getting, which will be equal to, so row 1 and row 2 as it is, B plus C, Q plus R, Y plus Z, C plus A, R plus P and Z plus X. See, what will happen to row 3? A plus A 2A, B plus B 2B, C plus C 2C, correct? So if you take out 2 outside, it will become A plus B plus C. Same thing here, P plus P 2P, R plus R 2R, Q plus Q 2Q. So again 2 you take out, it will become P plus Q plus R. Same thing here, X plus X, Y plus Y, Z plus Z, take out 2 outside, so it will become X plus Y plus Z. Alright, so now we will take this 2 outside, so we got the 2 here, correct? This 2 will take it outside, what will happen? 2 if you take outside, the remaining things will be B plus C, Q plus R, Y plus Z, C plus A, R plus P, Z plus X. The remainings are A plus B plus C, P plus Q plus R, X plus Y plus Z. Now what do we want here? We want APX, means we need A here, we need B here, P, Q, X, Y. Here we'll be needing C, R and Z. So students, the next operation what we are going to conduct will be R1, we will operate this as R1 minus R3. What will happen? You see, R1 minus R3, so B and B will get cancelled, C and C will get cancelled. What will remain out? A will remain out, correct? Similarly, R2 also, we will use the same operation, R2 minus R3. See what will happen again? C and C will get cancelled, A and A will get cancelled. What will remain? B will remain, correct? So we'll operate this now, which will be written as R3 as it is, correct? R3 we are not operating anything. Let us write R3 as it is. So here we'll write A plus B plus C, P plus Q plus R and X plus Y plus Z. R3 is done. Now we have to write only R1 and R2 with these operations. So R1 will be B plus C minus R3 is minus A minus B minus C. Same thing, Q plus R minus P minus Q minus R, and it will be Y plus Z minus X minus Y minus Z, correct? Same thing for R2 as well. C plus A minus B minus C, R plus P minus Q minus R, and Z plus X minus Y minus Z. So if you see here now, next, plus B minus B will get cancelled, plus C minus C will get cancelled, QR, YZ, correct? Here CA, RP, ZX and ZX will get cancelled out. Now what is remaining, we'll write that down. What is remaining here? That will be written as determinant of minus A minus P minus X. Here minus B minus Q minus Y, and here A plus B plus C, P plus Q plus R, X plus Y plus Z. This is what will be remaining. And 2 is written as it is. This 2, we'll write it outside here also, we will write 2. Now in the last row we need C, R and Z, correct? So A and B should get cancelled out. And we have minus A and minus B in the first 2 rows. So what we'll do, what is the next step is here? We will write R3 will be equal to R3 plus R1 plus R2. So once you write it like this, what is the next step? Here it will be written as 2 of R1 and R2 as it is. But here what we'll do, from R1 we will take minus 1 outside. Okay, this is coming from R1, and from R2 also we'll take minus 1 outside. So this is multiplication, 2 into minus 1 into minus 1. Alright, so this will become now positive A, P, X, and here it will be B, Q, Y. Now plus we have to do, right? What is R1? Minus A. So after taking common, minus 1 we got outside. So before taking common, what will happen? So this will become A plus B plus C minus A minus B. So this will become P plus Q plus R minus P minus Q, and this will become X plus Y plus Z minus X minus Y. So the same thing again, plus A plus B minus B plus P minus P plus Q minus Q plus X minus X plus Y minus Y. What is remaining now? I think we got the final answer. So this will be equal to 2 times of APX BQY. See the last row now, C R Z. Is this our RHS? APX BQY CRZ, and 2 outside. Minus into minus is plus, so which is equal to RHS. Therefore, hence proved. Starting with the next question. So again we have to prove that LHS equals RHS, and the determinant given us is of the order 3. So we have to prove that determinant is equal to 4a square b square c square. So students, what we'll do here, so observe the determinant on the left hand side. A is common, correct? We can take out a common from the first row. Is that right? Correct. We can take out a common from the first row, b common from the second row, and c common from the third row. So we'll be getting a, b, c outside, right? So here the solution, we can write it like this. Solution A, B, C. A is from first, B is from second, C is from third. So what will remain inside the determinant? Minus A, B, C. So this will be, B is going out here. So it will be A minus B and C. Here what will happen? C is going outside. So A, B and minus C will remain inside. Now again, so this ABC, whatever we took out common, that is from the rows. A from the first row, B from the second row, C from the third row. Next again we'll take out ABC common, but from the column. See, A will take from the first column, B will take from the second column, C will take from the third column. So this ABC is as it is. This ABC is as it is. Again we are taking ABC outside from the first column, second column, third column. Now what will remain inside? Minus A, B, sorry, it is not minus A. So once ABC goes out, only the numbers will remain inside, correct? So that will be minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. This is what will remain inside the determinant. Now we have to evaluate this. So if we evaluate this, I think we'll be getting 4. So before we evaluate, so let us try to make it even more simpler. So here what we'll do is, students, we will take column 2, or we will operate column 2 such that column 1 plus column 2. In this way we will operate column 2. What will happen to column 2, you see? So these both will get squared now. So that is becoming A square, B square, C square, correct? A into A, B into B, and C into C. Column 1 as it is, column 3 as it is, minus 1, 1, 1, 1, 1, minus 1. So column 2, what can we write in the place of column 2? Column 1 plus column 2, so this will become 0, correct? Column 1 plus column 2, 0 again. Column 1 plus column 2 will be getting 2. Now in this determinant, there are 2 zeros in column 2. So what we'll do, we will expand this determinant, or we will evaluate this determinant with respect to column 2. So before we evaluate with respect to column 2, we have to know the cofactors of column 2. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. Now evaluate or expand this determinant with respect to column 2. What will happen? So A square, B square, C square as it is. Okay. So of minus 0, so minus 0 into anything is 0 only, plus 0 into anything is 0 only. Now what do we have here? Minus 2 of the determinant. So the 2's column and the 2's row is gone. So 1 into minus 1. So what is remaining? Minus 1, 1, 1 and 1, correct? Yeah. So this is what is remaining inside the determinant. So after evaluation we are getting this much. Further simplifying this, A square, B square, C square of minus 2, evaluate this determinant, it will become minus 1, minus 1. So again A square, B square, C square of minus 2, minus 2. Minus 2 into minus 2 is plus 4. So 4 A square, B square, C square, which is our right hand side, therefore proved. So students, in this question, the first ABC is taken out common from the rows. The second ABC is taken out from common from the columns. So you can directly evaluate this only, but there are no zeros, right? If there are zeros, our operation will become very easier. So just to get some zeros, what are we doing? We are adding column 1 and column 2. Minus 1 plus 1 plus 1 minus 1. This will become 2. So we got 2 zeros. Expanding the determinant with respect to column 2, we'll be getting the answer as 4A square, B square and C square, which is our right hand side, and hence it is proved. Starting with the next question, again we have to prove left hand side equals right hand side. So here on the right hand side we have a determinant of order 3, and we have to prove that is equal to A minus B into B minus C into C minus A. So can we take out common? Any common possibilities are there? See, A is only present in row 1. Okay, in column 1. So here we have A, here we have A, but here we don't have A, correct? So if you see columns A, B, C, A, B, C, so taking out common is difficult here. So what we'll do here is we will make one small operation, students. The operation goes on like this. So solution. So the very first row transformation operation what we are doing is we will take R1. Okay, R1 minus R2. What happens if you do like this? R1 minus R2. So this can be written as, so R2 and R3 you write it as it is, 1 B, B square and 1 C, C square. Close the bracket. Okay, now R1 minus R2, 1 minus 1, 0. A minus B only, correct? A square minus B square, write it as it is, A square minus B square. Now why did we do R1 minus R2? You will understand in the next step. So if you simplify this, so further simplifying this, what we'll be getting? We will be getting 0, 1, 1, a minus b, b, c. What is a square minus b square? A square minus b square is nothing but a square minus b square is nothing but a plus b into a minus b, correct? And this will be b square as it is, and this will be c square as it is. So this is the determinant. Now can you take out common a minus b from the first row? See, a minus b we have here, a minus b we have here. Here what we'll write? So here we can write 0 into a minus b. What is 0 into a minus b? 0 only, right? So 0 into a minus b is 0 only. See, I am writing equal to symbol between these both determinants. Now take out a minus b outside from the first row. What will you be getting here is, so which is equal to a minus b, we have taken it outside. What is remaining inside now? 0, here we'll be getting 1, here we'll be getting a plus b, 1 b, b square, 1 c, c square, correct? So a minus b we got, next we have to get b minus c, similarly we have to get c minus a. So what is the next operation we are going to conduct here is, we will write, so R1 we operated, right? So for b and c, so we'll write R2 is equal to R2 minus R3. Why are we doing like this? Because b minus c. So what will this give us? So this will be equal to, so R1 and R3 as it is. So write that 0, 1, a plus b, 1, c, c square. Now operate this R2 minus R3, 1 minus 1, 0, b minus c only. This will become b square minus c square. Okay, outside what do we have? A minus b, write that also, a minus b. Now you see the second row, students. In the second row, okay, we have to expand this. This can be written as what? Same thing. A square minus b square can be written as a plus b into a minus b. Similarly, b square minus c square can be written as b plus c into b minus c. Take this b minus c outside. So 0 into b minus c is 0 only. So from here also you can take b minus c outside. So in the next step, what will happen, students? In the next step, a minus b is already outside. Now what are we taking outside again? B minus c we are taking outside now. So b minus c you took outside. So what is remaining inside the determinant? 0, 1, a plus b, 0, 1, b plus c, correct? B plus c into b minus c. B minus c went outside. B plus c is remaining inside. Next, 1 c, c square. What do we want more here? We want c minus a, and almost everything is 0 now. So what you have to do, we'll just evaluate this determinant. We'll keep this as it is, which is equal to a minus b into b minus c. So you will evaluate this determinant with respect to which row or which column now. So you see the column 1, we have 2 zeros there. So is it better to evaluate this determinant with respect to column 1 because there are 2 zeros? So before we start with the evaluation of this determinant with respect to column 1, write down the cofactors. So this is plus, minus, plus, minus, plus, minus, plus, minus, plus. So evaluate the determinant, open the bracket, plus 0, minus 0, only this is remaining, plus 1 of, so plus 1 of b plus c. So this is the determinant remaining, right? Cross multiply b plus c inside the bracket minus a plus b. Close the bracket. Evaluate this now. So here we have a minus b, b minus c. So of plus 1, b plus c, distribute this minus sign, minus a minus b, plus b and minus b will get cancelled. What is remaining? C minus a into 1 is c minus a only, which is equal to a minus b, b minus c, and c minus a, which is equal to right hand side. Therefore, proved. Hope you understood this question. So moving on to the next question, students. So question number 9, exercise 4.2, show that one determinant is given there, and we have to prove that is equal to x minus y into y minus z into z minus x of xy plus yz plus zx. So we have to prove this by using the properties of determinants, whatever we have studied in the synopsis. So what we'll do here, students, if you observe, the very first term is x minus y, right? So we have to get that x minus y. Okay. So what we'll do here is, you see the determinant, in the very first row we have x square, and in the second row we have y square. So by looking at the determinant, you have to get an idea. So let's start with the solution. So the very first operation what we are going to do is, we are going to do r1 will be equal to r1 minus r2. Why r1 minus r2? So now only we are operating r1, right? So r2 and r3 we will write it as it is. So here we'll write y, z, y square, z square, and this will be zx and xy. So r2 and r3 as it is. Now you see r1 minus r2, x minus y. Here we'll write x square minus y square, and here we'll write yz minus zx. Okay. See, we got x minus y here. We have x minus y here also, right? We got x minus y so we can we take x minus y common from this complete row? So simplify this further. So this again can be written as x minus y as it is. This can be written as x plus y into x minus y, a square minus b square. Here what we'll do, we take out minus z common. So if you take out minus z outside, so if you take only z outside, it will become y minus x, but we need x minus y, right? So take out minus z outside, what will happen? X minus y. So just multiply this inside, minus z into x minus zx, minus z into minus y, yz as it is. Okay, so these both rows are untouched, so we will write yz, y square, z square, zx, xy. So this is our determinant. Now you see the first row. From the first row, what can you take out common? X minus y you can take out common, right? So take out x minus y outside. So what will remain inside the determinant? X minus y of 1, x plus y, and here we'll be getting minus z. 2 and 3 as it is, yz, y square, z square, and zx, xy. Now see what is the next term? You got x minus y, next we'll try to get y minus z. So how do we do that? Again, y square and z square we have, y minus z we have. So we'll apply the operation r2 equals r2 minus r3. So for this, write x minus y of r1 and r3 are untouched. So write them first, 1z, x plus y z square, and minus z, xy. Now you start operating r2. r2 minus r3, y minus z. r2 minus r3, y square minus z square. r2 minus r3, zx minus xy. What are we trying to take out? Y minus z. So y minus z we got here. We'll get y minus z here also. How do we get y minus z here? We have to take out minus x common. So write that again. So x minus y of 1, x plus y minus z, y minus z, y minus z of y plus z. Take out minus x outside. So if you take out minus x outside, you will be getting y minus z. Check it once. Minus x into y minus xy, minus x into minus z plus xz. And this as it is, z square, xy. Now you see the second row. Can we take out y minus z common from the second row? We can. So write that again here. X minus y of y minus z of 1, x plus y minus z. So here we'll write again 1, y plus z minus x, and third row as it is, z square, xy. So moving with the next one, we have to take out z minus x outside now, correct? X minus y, y minus z, and z minus x outside. So take out z minus x outside, we'll perform another operation here, row operation. So we will write r1 equals r1 minus r2. So r1 equals r1 minus r2, what will happen? The very first element of R1 will become 0, students, correct? So 1 minus 1 will be 0. So we'll write this as it is again, whatever is outside. X minus y of y minus z of 0, correct? 1 minus 1 is 0. X plus y minus of y plus z. So y and y will get cancelled. What will remain? X minus z will remain. And minus z, minus of minus is plus. So again what is happening here? X minus z is remaining. These both rows are as it is. So we'll write 1 y plus z minus x z square and xy. We want z minus x outside, right? But we are getting x minus z. Take out minus sign common. Okay. So here also we have x minus z because anything multiplied by 0 is 0 only. So from the entire first row, we are going to take z minus x outside. So outside what we'll write now? X minus y, y minus z, and here we'll write z minus x. What will happen? 0 minus 1 minus 1. So this is 1 z y plus z z square minus x xy. This is what will remain inside. Now again after this, so one part is done, another product is there here, okay, if you can see in the question. So that we have to prove, but how are we going to get that? By solving this determinant. So before we solve this determinant, students, so there is only one 0 here, right? So we will make this also as 0. To make this as 0, we need a 1 here, but we do not have a 1, but we have a 1 on this side. So now what we'll do, we will operate with the columns. So column operations, so here we'll write C2 equals C2 minus C3, correct? Minus 1, minus of minus 1, that will become plus 1, so this will become 0. So means we'll write C1 and C3 as it is. So C1 is 0, 1, z, C3 is minus 1, minus x and xy. Now operate C2, C2 minus C3, minus 1, minus of minus 1, 0. Y plus z, minus of C3, so that is minus x, so this is becoming x plus y plus z, correct? And this z square minus xy, as it is z square minus xy. What is outside? Write that as it is. So that is nothing but x minus y, y minus z and z minus x. Now evaluate this determinant with respect to which row will you evaluate this? So we have to evaluate this with respect to the first row. Why? Because there are maximum number of zeros here. So 0, 0 and minus 1. Write down the cofactors plus, minus and plus. So plus 0 into anything is 0. Minus 0 into anything is 0. And finally we have plus of minus 1. So these both are gone. Open the bracket. Z square minus xy as it is. Z square minus xy minus of z into, so that will become z into x plus y plus z. So this and another bracket here. Okay. Now evaluate this. So this is becoming 0. This is also becoming 0. Evaluate only this much. Plus into minus is minus. So minus of z square minus xy minus, multiply this z inside first. So it will become zx plus yz plus z square. Close the bracket. Distribute this minus sign inside. Minus of z square minus xy minus zx minus yz minus z square plus z square minus z square will get cancelled. Minus, take out minus common. So what will happen? There is already a minus outside. So if you take out another minus common, minus into minus will become plus. So what is outside here? So this is, you should write here as well as here. So finally we can write x minus y into y minus z into z minus x. Minus into minus will become common, right? So here we can write xy plus yz plus zx, which is equal to RHS. Therefore proved. Okay. So students, in this problem, what we have seen is they have given a question and they are telling us to prove the left hand side is equal to right hand side by using the properties of determinants. But what we did, we used row transformations here. By using row transformations, we have proved. So we have to just prove either by using the properties of determinants or by using the row transformation. Starting with the next question. So here we have to show that the given determinant is equal to k square of 3y plus k. So students, you observe this determinant
and now we have to get 3y plus k, correct? So see here 3y plus k. So observe this determinant, see what will happen if you,
so solution will start like this. R1 equals R1 plus R2 plus R3, correct? So add all the rows now. So what will happen? R1 is only getting changed. R2 and R3 are as it is. So finish writing them first. Y plus k, y of y plus k. Now see the R1. Y plus k plus y plus y. So y plus y plus y is 3y plus k, correct? So here we'll write 3y plus k. Same thing here. Y plus y plus y plus k, y plus y plus y plus k. So this will become 3y plus k and 3y plus k. Can you take out 3y plus k outside now? Yes. So take out 3y plus k. 3y plus k common from the first row. You will be getting 1, 1, 1. Y plus k, y plus k again.
Okay. Now what we'll do, students? So see, here we have 1, here we have 1, here also we have 1. So we'll do the operation C1 minus C2. So C1 minus C2, 1 minus 1 will become 0. After that we'll do C2 minus C3, again 1 minus 1, that will also become equal to 0. So for this matrix, for this determinant, so here we'll write C1 equals C1 minus C2, and for the same determinant we'll write C2 equals C2 minus C3. Okay. So what will be getting? This will be as it is, 3y plus k as it is. So which column is not getting disturbed here? C1 and C2 are getting disturbed, right? C3 is untouched. Write C3 first. So we'll write here 1 y plus k. So that is as it is. Now what we'll do here, in between, we'll apply this operation. So from this determinant, okay, C1 minus C2. C1 minus C2 is 0. C1 minus C2, y minus k. So minus k will get remained. Plus y minus y will get cancelled. C1 minus C2. So y minus y is again 0. Again from this determinant, C2 minus C3. So C2 as it is. Okay. So 1 minus 1 is 0. Y plus k minus y is k only. And y minus y plus k. So that is becoming minus k. So this is what we got. C1 minus C2, C2 minus C3. Here now again we will take out the determinant. So writing down the cofactors plus, minus and plus. So this is becoming plus 0 of, okay, minus 0 of, that is becoming plus 1 of k square, and this is becoming minus 0. Correct? What do we have outside here? Here outside we have 3y plus k. So this is 0, this is also 0, only this is pending now. So we are writing 3y plus k of k square. Is this our right hand side? So which is equal to RHS, therefore proved. The next question, 11th one, second sub question. The left hand side determinant we have, right hand side we have an expression. So we have to prove that LHS is equal to RHS. Okay. So students, you see the left hand side and the right hand side. So on the right hand side we have 2 times of x plus y plus z. So that is nothing but 2x plus 2y plus 2z. The whole cube is there. So let us just now ignore this whole cube. Only concentrate on 2 of x plus y plus z. So how do we get 2 of x plus y plus z outside? So you see the determinant here again. So 2z is there, 2x is there, 2y is there. What is missing here? 2x is missing, 2y is missing. Here 2z and 2y, here 2z and 2x. So how do we get it? So can we get that by adding the columns? Correct? So column 1 equals column 1 plus column 2 plus column 3. Correct? Column 1 as it is. So to this what will get added up? Column 2. So it will become 2x. Again y will get added up, it will become 2y. So we'll write the solution here. Solution. Column 1 equals column 1 plus column 2 plus column 3. So we'll leave the column 1. See, C2 and C3 are unchanged. So we'll write that as it is first. So here we'll write x, y plus z plus 2x and x. So here again y, z plus x plus
2y. Correct? So now we will write the column 1. So column 1, this plus column 2, this is getting added to this, plus column 3, this is also getting added to this. So x plus x, 2x, y plus y, 2y, and this is 2z. So take out 2 common, what will remain? X plus y plus z. Same thing to this is getting added up. So z plus z is 2z, y is also getting added up, y plus y will be 2y, again 2 common, x plus y plus z. Same thing, 2 of x plus y plus z. So from column 1, what can we take common now? 2 of x plus y plus z. So 2 of x plus y plus z, if you take out common, what is going to remain inside? 1, 1 and 1. Here it will be x, y plus z plus 2x, x again, y, z plus x plus 2y. This is our determinant. Now again we have 1, 1 and 1 here. So we'll make these both 0. How do we do that? We'll make use of row transformation. So row transformation can be written like this. R2 equals R2 minus R1. So students, see, you can directly expand like this. But if you expand it like this, okay, this will take some time to expand the determinant. So what are we doing? We are trying to get zeros here. So once we get zeros, okay, expanding will be easy and the time taken also will be less. So that is the only reason. So R2 minus R1 will do. We'll see what we'll get. So we are already having 2 of x plus y plus z outside. Okay. So we'll also do one more operation. R3 is equal to R3 minus R1. So this will also become 0, right? 1 minus 1, 0, 1 minus 1, 0. So these both are 0. So R2 and R3 are getting changed. R1 is not getting changed. So let us write that first. 1 x y. So R1 is finished. Now we'll start writing R2. R2 minus R1, 1 minus 1, 0. R2 minus R1, y plus z plus 2x minus x. So what will happen? Only x plus y plus z will remain here. Correct? So here what will happen? R2 minus R1, y minus y, 0. Same thing, 1 minus 1, 0. X minus x, 0. And z plus x plus 2y minus y will become x plus y plus z. Now see, there are 2 zeros in the first column and there are 2 zeros in the last row. You can expand the determinant with respect to any row or column. So let us expand here with respect to the first column only. So before we expand, we have to write the cofactors. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So we'll expand with respect to first column, write this as it is. 2 of x plus y plus z, open the bracket, plus 1 into, so plus 1, x plus y plus z the whole square, minus 0. That's all, right? So minus 0 into 0, minus 0 into something, plus 0 into something, close the bracket. So this will give us 0 because anything multiplied with 0 is 0. This will also give us 0 because anything multiplied by 0 is 0. Only this thing is remaining now. So 1 times of this and it is multiplied with. So it will become 2 of x plus y plus z into x plus y plus z the whole square. So which is equal to 2 of x plus y plus z the whole cube, which is equal to RHS, therefore proved. So students, observe the pattern here. Each and every time what are we doing in each and every problem is, based upon the right hand side, okay, we are deciding a random operation here. So how is this random operation decided by us? By looking at the right hand side. So once we get that right hand side outside common, then what we are doing, then we are evaluating this determinant, but before we evaluate, we are performing such row operations. Why are we performing such row operations? Because to get zeros like this. So once you get zeros, you see, no need to work out these both things. Directly you can write it as 0 and finally you will be getting the right hand side. So just follow the same procedure and you will be reaching the right answer. Understood? The last question of exercise 4.2. So we have taken an MCQ question here. So let A be a square matrix of order 3 cross 3. Then determinant of Ka is equal to, and they have given 4 options, students, A, B, C, D. So here you can either take an example of a determinant, okay, multiply that with a constant, check out the value of that, okay, you can do like that, or you can also consider the variables as an example. So we'll be doing both the ways and we'll see what are the answers. So the very first method what we are going to start with is we'll take some variables first. Then we'll take with a real determinant, means with numbers. Okay. Let us consider a square matrix. Okay, so let us take solution here. Okay. So let A be a square matrix, correct? So here we'll write matrix A of order 3 cross 3 is given as A1, A2, A3, B1, B2, B3, C1, C2 and C3. Okay. Of order 3 cross 3, then determinant of K into A. So K into A means what will happen? So this is only A, right? So now we'll write K into A. So this can be written as KA1, KA2, KA3, KB1, KB2, KB3, KC1, KC2 and KC3. So this is matrix K into A. Okay, scalar multiplication of matrix. Now what will happen? Determinant of K into A, right? So determinant of K into A. So this is nothing but determinant of KA1, KB1, KC1, KA2, KB2, KC2, KA3, KB3 and KC3. Take out K common from the first row, take out K common from the second row, take out K common from the third row. So 3 K's are coming outside, right? So therefore determinant of K dot A will be equal to K cube of determinant of A. So this will be our right answer. So the same thing. So here what you can do, students, you can try this. You can assign some values for A1, A2, A3, B1, B2, B3, C1, C2, C3. So I'll just write down, you can try this one. So let A1 is equal to -1, B1 is equal to 1, C1 is equal to 2, A2 equals 3, B2 equals 4, C2 equals -6 and A3 equals -3, B3 equals -1 and C3 equals 4. And you can take K is equal to 2. So what you have to do here is substitute these values, multiply the constant K, see whether this is equal to this side or not. So obviously it will be equal because it is satisfying with the variables. It will obviously satisfy with these values as well. So you can try this and let us know whether you are getting the right answer or not. So here we are going to stop with this exercise, continuing with the next exercise 4.3 in our next class. Thank you, students.